So again, here's another exponential growth problem, and we probably should set up some points. Now, what I did in class was we walked through, we let people try this on their own. A couple people needed some help getting started. So what I'll do right here, if you're watching this at home and I want you to try it, what we need to do is we're starting with 100 fruit flies, so that tells me times 0, we have 100. So there's a point. And then we have 300 flies on the second day, so that tells me after day 2, we have 300. Now what you should do is probably stop right now and try to do that same idea of taking that information and trying to build an exponential model with that same technique we've been using. So, assuming you've stopped it and you're not just watching through, I'm going to go on with this. So I know that y is 100, and b is 0. I know that y is 300. When x is 0. And I know y is 300 when x is 2. And I'm doing the same process, except I know that this is a times 1, because b to the 0 is 1. And this I can say that 300 over b squared equals a. So then I can say that a must equal a. So 100 has to equal 300 over b squared. And I can write this as 100 over 1. Then I'm going to find the cross products. So 100 times b squared has to equal 300 times 1. I'm going to divide both sides of this equation by 100. Then I'm going to take the square root, and I don't want the negative square root. I'm going to deal with the positive square root. You can express this as a decimal or just using that radical form. I'm going to leave it in radical form. So my equation is y equals 100, because that's my initial value. That's what a was, right, on the other side, times the square root of 3 to the x power. Then they're asking us, if you go back and look at the question, they said, how many fruit flies will they have after 10 days? So I'm just going to take 100 times the square root of 3 to the 10th power. So 100 times the square root of 3 raised to the 10th power, 110. So 24,300. Then they're asking us how mathematically, how long it will take for a billion flies. Well, since we don't know how to solve an exponential equation like that yet, we're just going to do some guessing and checking here. I'm going to try 50. And that's a whole lot more than a billion, right? Because it would be 8 times point whatever times 10 to the 9th, right? Because there's 9 zeros in a billion. So it's going to be a whole lot less than 50. Let's try 20. So that's about 5, almost 6 million. Closer. Let's try 25. I'm trying to go for a billion, aren't I? So let's see, that's 92 million, so I can go a lot higher. Let's try 35. Well, that's, let's see, won't that be 20 billion? So we got to do less. That's about 1.4 billion. And that's just a hair over a billion, so 29.5, 29, somewhere along those. I'll stop there. But hopefully that worked for you and got the idea.